Hi guys, welcome back to our channel. Today we will continue learning about acids, bases and salts. I'm Rahul Dogra and this PPT has been made by Amulya. So let's start without any further ado. We will be learning about two topics, neutralization and neutralization in everyday life. Now before we continue forward, let us just do a small recap on what we had learned last time, right? So what we had learned is about acids and about bases, right? A and B. So we had learnt one of the differences between them, that acids are sour in taste while a base is bitter. Not only is it bitter, but it also is soapy or slippery. It's of slippery texture, right? And we had also studied about different examples of acids and bases, such as most cleaning materials are bases, such as toothpaste, detergent, washing powder, etc. As for acid, a lot of things we eat have acid in them, such as orange, lemon, and so on, right? So that's it for acids and bases. We had also learned about different natural indicators. What are natural indicators? That's what we use to differentiate between an acid or a base. So two of the popular ones were litmus and turmeric. Now, anybody remembers what litmus turns into when it's put into an acid or base? Well, I'll tell you. A litmus turns red when it's put into an acid, and it turns blue when it's put into a base. For turmeric, it's a bit on the opposite, because the turmeric turns red when it's put into base and it turns yellow when it's put into an acid. Right? That's it for the recap. Now let's get started with these two topics. Let's get started with our first topic, neutralization. Now, what exactly is neutralization? It basically means balancing things out. Like, let's say you're taking a bath, right? And the water is too cold. Now what will you do? You won't just bath with the cold water, right? You'll put in some hot water so it becomes normal temperature so that you can take a bath with it. That is basically neutralizing. The hot and cold water neutralize each other out. And now we'll see how an acid and a base neutralizes each other, right? Next slide. Neutralization. When an acidic solution is mixed with a basic solution, both the solutions neutralize the effect of each other when mixed in suitable amounts. This resulting solution is neither acidic nor basic. You guys can see the example given below. Acid plus base gives us salt plus water outcome, along with heat is evolved. Heat is evolved basically means that this is an exothermic reaction. I'm sure you will learn about this later on, but just to give you guys an idea, exothermic means that heat is evolved, heat is given out, while endothermic means that heat is absorbed for the reaction to take place. Right? Now, a reaction between an acid plus base is called neutralization, and the outcome we get is salt and water. Now, the salt could be acidic, basic, or neutral in nature, depending on whether the acid is strong or base. Like if it's a strong acid plus weak base, then the salt will be acidic. If it's a strong base and weak acid, then the salt will be basic. While if both the acid and base are strong or weak, then the salt will be neutral in nature. Right? Now, here you can see an example given below of a actual chemical reaction. Hydrochloric acid HCl plus sodium hydroxide NaOH will give us sodium chloride NaCl, or salt plus water H2O. Now going ahead, you guys will have to do a lot more complicated chemical reactions. This is a simple one, but just to give you guys an idea, you can see that both of these sides have the same number of molecules, right? You need to make sure in every chemical reaction that both sides have the same number of molecules. Wait, I'll show you. Like over here you see Na, and over here also Na, 1. then Cl over here, and Cl over here. While for OH, you can see that two hydrogen molecules, right? This will be over here, and the one oxygen molecule over here. Like both of the sides are balanced out. So you need to make sure to do this for every chemical reaction you do in the future, right? Okay, now let's see what else is. Did you know? Have you guys heard about acid rains? Well, as the name indicates, and it's obvious, acid rains mean rains which have acid or are acidic in nature, right? And these rains can be very harmful to us because acid rains damage buildings, monuments, and they're also harmful to plants, animals, and us too in general, right? A famous example of a monument getting damaged by acid rain is Taj Mahal. In fact, Taj Mahal used to be white, but because of acid rains, it has started turning yellowish in color because its marble has been damaged by acid rains. Now, how does rain become acidic? Well, because of pollution. Pollution turns rain acidic. Pollution releases harmful substances such as carbon dioxide, sulfur dioxide, and nitrogen dioxide, which are gases, harmful gases, which pollute the air. These harmful gases go up into the sky and mix with the clouds, right, to form carbonic acid, sulfuric acid, and nitric acid. Now, this acid, when it rains, falls down with the raindrops and causes damage, because of which we need to be aware of pollution and reduce it. Okay, now let's move ahead. All right, guys, it's activity time. Now let's get ready for some fun activity. For this experiment, let's use a new indicator called phenolphthalein. Now, what is phenolphthalein? It's a natural indicator that we use to differentiate between acid and base. Remember last week we had learnt about such natural indicators such as litmus, turmeric, etc. Well, phenolphthalein is also like that, right? So let's get started. Okay, guys, let's get started with our activity. Now, of course, we all are at home and not at the lab. That's why we can't do it right now. So you guys can just note it down. And when you do get a chance, do it at the lab. Even if you don't, that's completely fine because I'll be doing it right now together with you guys. So let's get started. Step 1. Fill 1/4 of a test tube with diluted hydrochloric acid. Okay, so let's make a test tube. Okay, it looks like a test tube, so it's fine. And fill 1/4 of it with hydrochloric acid. Now, hydrochloric acid is actually colorless, right? So I'm going to use white to denote hydrochloric acid, but it's actually colorless. So this is hydrochloric acid. Then step 2, note down the colors of hydrochloric acid and phenolphthalein. Now guys, a unique thing here is both HCl and phenolphthalein are actually colorless. So we'll use white to denote both of their colors because they both are colorless. Okay, then step 3, add 2 to 3 drops of the indicator, which is phenolphthalein, to the test tube and shake it gently. Okay, so we have our test tube over here, which is filled partially by HCl, and we add a bit of phenolphthalein to it, right? Okay, it looks fine. So step 4, do you observe any change in the color of the acid? Answer is no. Well, yes, when you add HCl, no, when you add phenolphthalein to HCl, it will actually not change color and remain colorless. Why is, we'll see in the next activity when we try the same thing with a base. Alright, so let's move on to the next activity. Okay, so continuing on with the activity, now comes step 5. Now we add a drop of sodium hydroxide, which is a base, to the acidic solution by a dropper. Okay, so this is our test tube. filled with hydrochloric acid and phenolphthalein, a bit of phenolphthalein. And to this we add sodium hydroxide, right? NaOH. And NaOH is white in color, like its normal color is white. So we'll drop a white sodium hydroxide drop into the solution. And when you stir the tube slowly, you will notice that the solution turns a bit pinkish, light pink, right? So now what we'll do is we'll continue adding NaOH until it turns fully pink. Now, why is the solution turning pink? Is it because of sodium hydroxide or because of phenolphthalein? Well, we'll get to know soon enough. For now, we can say that the solution is turning pink. Right? Yeah, like this. Then step 7, when you add another drop of hydrochloric acid, the solution will again become colorless. Okay, so what did you learn from this? When you add hydrochloric acid, it becomes colorless. When you add a base, it becomes pink. So it's obvious that phenolphthalein will become pink when you add it to a base, while in acidic solutions, it will remain colorless. It won't change its color. Right, so this small activity was just to know how phenolphthalein reacts with acid and base and to give you guys a breather because we have been learning theory since the start till now. Right, so okay, now the activity is done. Now let's move on. Now let's get started with our second topic, neutralization in everyday life. Now we'll be seeing how exactly do we use neutralization in our life to help us. Right, so let's get started. Timeline process. Now the DNA looking thing below is actually a list, an index of what we'll be seeing ahead. We'll see how we use neutralization for indigestion, ant bite, soil treatment, and factory wastes. Indigestion. Now remember guys how I had told you last time about acidity, like how our stomach creates acid to digest food. Well, that acid is called hydrochloric acid. We can see it over here, hydrochloric acid. And when too much acid builds up in our stomach because we're eating acidic food, or if we are not eating anything, so the acid starts building up, we start having indigestion or stomach pains, right? So how do we take care of that? We take care of that through milk of magnesia, which is an antacid. Milk of magnesia helps with digestion because it contains magnesium hydroxide, right? And magnesium hydroxide is the base. So what basically happens is the acid in our stomach and the base that we eat, it kind of mixes with each other, because of which it neutralizes the effect of indigestion. Means it helps us take care of the pain. That's why whenever we have acidity, we usually eat or drink something which is basic in nature, such as lime juice, so that the pain reduces. Ant bite. Now, if you guys ever have had an ant bite you, you will know that it starts stinging or hurting in that area, right? Well, that is due to formic acid. When an ant bites you, it releases formic acid onto your skin, and this actually causes the sting and hurt. So how do we take care of that? Again, I'm sure you must have guessed it, through neutralization. We rub a base on our skin, the area where the ant has bit us, to help neutralize the acid. Now we can rub either moist baking soda, which contains sodium hydrogen carbonate, or we can rub calamine solution, which contains zinc carbonate. So the next time an ant bites you, you know what to do, right? So let's move on. Soil treatment. Now, when farmers grow crops a lot on the same land, the fertility of the soil reduces, right? Because of which plants do not grow that good. So to increase the fertility again, we use fertilizers. Now the problem with fertilizers is that fertilizers are acidic in nature, right? And plants cannot grow too well when the soil is too acidic or even too basic. Plants need alkaline soil. Alkaline means when it's neither too acidic, neither too basic. It's in the middle of the two. So again, we do have a treatment for that. When the soil gets too acidic, then we can treat it with bases like quicklime or slaked rind, both of which contain calcium oxide and calcium hydroxide. And if the soil gets too basic, then we put in organic matter, composite pit, right? Like when you put fruit peels such as banana peels, apple peels, or anything of that sort into the soil to make it more fertile, that thing releases acid into the soil, which helps neutralize the soil from the base, right? So that's what farmers usually do when the soil gets too acidic or too basic. With that, let's look at the last example. Factory wastes. Now we know that factory creates a lot of waste, right? They do air pollution, water pollution, and stuff like that. Now we can't do much for air pollution, although we can do a bit for water pollution. Now the reason water pollution happens is because of the waste which they put into water bodies is actually very acidic in nature. And this acid will kill the fishes, the plants in the water, and basically not make it drinkable. So we can neutralize this by adding basic substances as well into the water along with the acidic waste, which will neutralize each other and not make it that harmful. It won't kill off the fishes and other organisms. Because of which factories put basic substances along with their acidic waste into the water. Right? That's it. Thank you. So hopefully you guys didn't fall asleep watching this video and learned something. So guys, stay safe, stay focused, keep studying. Yeah. See you guys next week. Bye.